Hello, everybody. This is the first of the videos that I'll be making on data structures. And this part is what I told you yesterday is not in the book. It's used in the book constantly, but it's really a 104 topic. And I'm going over it again because some people didn't have it. And those who had it probably could take another chance to go through it and make sure they remember it. We have up to this point looked at variables that contain characters and integers and booleans and floating point numbers. We now have a different kind of place. It's another box inside the computer, another place in memory, but instead of holding one of those other kinds of data structures we were talking about, it holds a pointer. It holds an address. It tells us where something is. Very often, we don't have a name for what it's pointing to. All we know is if we want to get to it, get to what it's pointing to, we have to go through the pointer. This allows us to create lots of variables as we're running a program and not bother trying to put names in them and help us. We can create a set of them that are linked together to make it easy to use them. I show this in pictures by showing a box with a pointer coming out of it, pointing to another box. Each of these boxes represents some space in the computer. How much isn't relevant right at the moment. We don't care. This contains a number that is the address where we would find this inside the computer. It'll be an unusual number. We'll see it in a minute. We usually don't look at it because we let the machine take care of that. Now let's go on a little. Here's how you declare a pointer. You should read that as next points to an int. So next is a pointer that holds the address of int. Next is not an integer. It's a pointer to an integer. If you're going to declare two of them in the same line, you have to use an asterisk in front of both of them. Otherwise, it will interpret the second one as an integer. That's a very common mistake. I think I made it a few times during the summer. So you have to be careful of that. So I'm going to write a little program to look at this. Now I have it all written out, so I'm just going to bring it over. It's easier that way. We won't spend a long time with my typing. Here's the program. What I'm doing is I'm declaring two pointers, and I'm declaring a variable, and I want to show how those items I just said actually work. So here are my two pointers. Back and next are both pointers. And I have the usual integer variable OB. Nothing big. This line is extremely important. We'll be using that kind of line constantly. Absolutely constantly this semester. We'll be using this line or something like it. It's a new operation, the operation called new. What new does is two things. First, it creates a new place in the computer that is of type int. So it goes and gets a place in the computer. Technically, I think it pulls it off what's called a heap, which is the space that hasn't been allocated to any variables yet. And it's an integer. It will be treated as an integer when the computer plays with it. Now, the second thing it does is it returns the address of integer, of this int, this new int. So this side is the address of the new space I just created. I take that address and I copy it into next. And that's perfectly okay because if you remember, next is also an address. So I'm copying an address into an address. Then this next line you have to be careful of. Star next. Well, up here, star next was a pointer to int. So down here, pardon me, I made a mistake there. Star next is the box that has the integer. It is the place where the new integer is. And it's just as if we wrote the name of that new integer, the anonymous name that we don't know. And what are we storing in it? 3. So when that line is finished, next will point to a variable that has a 3 in it. And we have no name for that variable. The only way we can get to it is to go through next. The next line, you should have some idea of this. Think back. We used this in 103 when we talked about functions. In 103, that was read as the address of OB. That's what it is here. So the right-hand side of that equation is the address of OB, and I'm copying it into BAC. Now I'm going to run just that much to show you what happens. And here's the answer. And what I'll do is I'll bring back this up to here, and that's, we can see what's going on there. Value of what next points to is, well, there's a little more hanging out on the side there. It's star next. Star next is what next points to, so that's the 3. Star back is what back points to, and that's 9. Because if you'll remember up here, we made the back be the address of OB, and OB is 9. This line I'm going to call a dirty trick. This is a way inside a function that you can do a side effect you're not supposed to do. And in fact, I'll show you how you protect against that happening. I never gave the function OB. I gave it a pointer to OB. Well, by using this method, I can change OB. Because on the left-hand side here, star back is the box that contains OB. Back points to OB, so back, what back points to is OB, and I'm putting 8 in it. And now, if I write out OB has become 8, even though I never had a line OB equals 8. That's a side effect. It's not sort of playing a little on the edge. You're not supposed to do it inside functions, but I wanted to make sure you realize that it could be done. This next line is something I don't usually do. I wrote out the address because I wanted you to see what an address looks like. This address is 8 digits. And if you look at the digits, some of them are letters. That's because this address is in base 16. And base 16 has 16 digits. 0 through 9, that's 10 of them. And then A, B, C, D, E, F. A represents 10, B represents 11, and so on up to F representing 15. An address inside the computer for our machine is 32 bits. So we have a 32-bit machine. Now, I don't want to see 32 bits. If I had to see the address as the machine sees it, I'd have a line of 32, either zeros or ones, stretching over here. And I'd have a lot of trouble figuring out what it is. Instead, we work with the address by translating it into base 16. Each digit you see here represents 4 base 2 bits. It represents a string of ones and zeros of size 4. 8, for example, represents 1000. 6 represents 0110. 9 represents 1001. B represents, it's 11, so it's 1011. Now I can do those quickly because I'm used to it. I don't expect that you could do it that quickly, but you can make up a table of the replacements for each of the hexadecimal digits. Again, I'm using this to show you that this is the way addresses look inside the computer. They are numbers, but they're 32 bits long, which means for our machine, they take 4 bytes to represent one address. So that's the first program I want to look at. And we've done some of it. So now I have to bring over my second item I want to show you. So I bring this in and bring this down. This is also out on the web. This is Data Structures 2, Notes 2. Remember, there's a Notes 0. That was the one I talked about yesterday. This is a 104 topic, but it won't hurt to look at it again for those of you who had 104. And for those who didn't get to it in 104, you'll need it, so I want to make sure we go over it. And if you have any troubles with it, let me know. If any of you have any troubles with it, let me know. We are trying to come up with a way to have a representation of, let's say, a waiting list, a waiting line. Now, the British call that a queue, and that's what we usually call it also, a queue in computer science. A waiting line has people in order. Now, I did not write this as a waiting line. Instead, I'm going to do this a little differently. My example is going to be an ordered list of names. To realize that, the first thing I have to do is represent what's going to be in that list. What is an element of that list? And that's where I use struct. This line here, and this is the program I'm working with, that line creates a new user-defined data structure called node. And node has 2 pieces in it. One piece is called value and has a string in it. The other piece is called next and is a pointer to a node. Now, while these words aren't necessary, they're very much used. The elements of many of the data structures we look at this semester are often called nodes. And the pointers to the next one are very, very often called next. I've also introduced a word here that's new, the word no. You will notice that no is in 4 capital letters. And you probably remember from the year of programming in 103 in C++ that C++ is very fussy. There's a difference between an upper U and a lowercase u. So that has to be in uppercase or you get yourself into trouble. I represent a no pictorially as 2 boxes. One box represents the value, one box represents the pointer. These are 1 unit. I don't particularly care how the computer stores them, how it manages to keep them together as a unit, but I view them as a unit. Now, if I write node names point to no, what I'm saying is I'm creating a new list. I'm going to create a list of names. Those names are going to be ordered in this particular case. The name of my list is names. Think of it this way. If I weren't doing a linked list, I could write names bracket something and create an array. It too is an ordered list of names. Or I could write a vector of string, and it too could be viewed as an ordered list of names. I have choices for how I want to represent it. Some of them are good for one thing I might want to do, some are good for something else I might want to do. I want to show you that we can do it with linked list. Now let's look at the beginning of an example. Suppose I have 3 names. The names are Albert, Mabel, and Veronica. And I've already put them in the computer. Albert is the one closest to the beginning of the alphabet. So I've created a node with Albert in it, and I pointed names to it. And then Albert's next points to the next person, in this case, Mabel. And Mabel's next points to the next person, Veronica. And Veronica is the last person in this list. So it's only a 3-node list. How do we get to this piece right here? We have no name for this node. It's anonymous. It was created probably with new. And new did not return a name. New returned an address. The address is what's in names. We need some way to get to the pieces of this node. The notation for that brings in a new operator. The operator is the dash followed by the greater than sign. You can read it as an arrow if you want. What it says is names point to is what names points to. Names points to is a name we can use for this part right here, Albert and its pointer. It's a strange name, but that's okay. Names points to it, so if I write names points to, that is it. And once I write that, it's a node. So I can have a value portion of it and a next portion of it. I do not use the dot. This is inconsistent. If they were being consistent, they would have put a dot there, but they didn't. Now I'll give you some examples. If I print names point to value, here's names, it points to Albert. It should print out Albert, which it does. Then I get fancier. I say I'm going to create a new pointer. I'm going to let temps be names points to next. So names points to next is this box right here. So names points to next is a pointer to here. Since it's a pointer, I can write names point to next, that's a pointer, what it points to, and then its value. And that will produce Maple. And I can do that in other ways too. But you got to get used to that pointer notation and that symbol for the pointer notation. The next thing I've got on this particular page is a program that I wrote so many times last summer I could probably have written it in my sleep. It's a program we use over and over. Its purpose is to print out all the elements in a linked list. Variants of it are used in different ways, different linked lists. The same kind of ideas are going to come when we're printing out other data structures. What I call it is, I'm going to walk down the linked list. I'm going to start where names points to, and I'm going to follow the pointers. And each time I get to one of the items, I'm going to print it out. So I'm going to have, I am printing what the list that is pointed to by InList. This is a function. So the first thing I do is say, I want to copy that pointer. Remember, it's a pointer to the first element in the list. So I copy it into temp. Again, I use the word temp constantly. Now I say, if temp doesn't equal null, then there's something in the list. Print out the value of what temp points to. And now walk down the list. Take temp point to next, which is the pointer in what temp points to, and copy it into temp. We've moved down one node in the list. And now we just go back up here. We keep going until temp is null. When temp is null, that means there's no temp.next, and we're at the end of the list. So that's a very common program. Now this, I'm going to bring up another program right now. So I have to go over here. First I have to get rid of this. Then I have to find somewhere over here the program I'm looking for. You can see a Python program there. Let's see, I got so many things open, I don't know what's happening. I'll find it sooner or later. That didn't work very well. Let me go down here, I can get it that way. There we are, there's the program. And I'm going to change it to the second program I want to look at. So I close this solution and I open my second program, which is here. Now here is a program that you'll notice I have the function plist in it. The function I just wrote for you. It's down here. As usual, it's there. And I'm writing another function called add to list. And what add to list is going to do is take a list and it's going to take a pointer to a new value and it's going to put that new value where it belongs in the list. And the program itself reads in names one by one. And each time it reads in a name, it puts it in the list. Then once I get it entirely read in, I will then search the list for an element I want. Now, let's see. I think that I do have a search somewhere here. Oh, string inval is what I'm going to be searching for. Pardon me. Inval is what I'm going to be reading. And I keep adding them to the list. And I'm going to show you what the list looks like. Adding a variable gets complicated. So let me bring up the thing I was looking at a minute ago. Wrong one, the other one. This is the algorithm. It looks terrible, but let's look at it as an example. That's the actual program which I'm working, is the one you're seeing. I think I wrote it down. That's the result of what I'm going to get. I didn't write it. I'm sorry. All right, let me go back up here and try to show it in this section. Let's suppose I'm going to copy this. It's about right here. I'm going to copy. Control-C. And I'm going to produce a new place here. New. And I'll have Control-V. Now, here's my question. I can't do some of the things I want to do, but that's okay. I want to add get rid of that. Nope, that's not going to work. That's going to work, I think. Nope. All right, I'm going to try to get down here and see whether I can do it without a problem. Yeah, that's going to work. Now let's suppose I want to add, let's try Adam. Have to see if I can make that bigger. Font. Make it 18. So I want to add Adam. But where should Adam go? It should go before Albert. So what I do is I find out it should go before Abbott. And now I have to take this item and I'm going to make some changes. First of all, I'm going to take this pointer. And, well, I need that pointer. The first thing I'm going to do is create a new node. So I'm going to take one of these nodes. I'll take this one. See if I can take both of them at the same time. I'm going to copy it. And I'm going to move it up to here. I'm going to paste it right here. And move it over a little. Now I'm going to create that, and I'm going to put Adam in there. So that's the first step. I have to create a node with my new element. Then I'm going to take the pointer. I'm going to take the pointer that points to Albert. It's in names, and I'm going to copy it. I'm going to move it over here so it points to Albert. And then I'm going to take names, and I'm going to boy, this is tough, because I can't get to what I want. Well, what I'll do is I'll copy one of these, and I'll put it right here. And copy V, and I'll just take it. And I think I can pull it out a little, maybe. But as you can, I hope you can see that now names points to Adam. So you're rearranging pointers. The same kind of thing would happen at the bottom. The more difficult case is if you want to put something in the middle. So let me copy this again. And then I'm going to go down here. And now I'm going to say, let's add Susan. Now, Susan should go between Mabel and Veronica. So I'm going to take this, and as I always seem to have happened to me, it's going off the page. So let me bring it up. I think I can get enough room so we can see it. Move up there. I think that may make it. Yes. Now, as I did before, I'm going to create a new node. So I take this, pardon me. Nope. One more try. There we are. I copy that, and I move it up here. And now this is my new node, so I'm going to move it over here. And I'm actually going to move it down here, make it easier. And I put Susan into this. Now I have to be very careful of the order I do things here. I want Mabel to point to Susan, and I want Susan to point to Veronica. So the first thing I should do is I should copy what is here into here. So now I'm going to have a point there. And then I need to point this downward. You have to do that in the right order or you get yourself in trouble. And the program does show that. If you look at the program itself. I can't get it to move over. Maybe this will work. Give me just a second. Yeah, that's working. And now I just have to find it. It's hiding underneath there, and I can't get to it. So let me try once more. I'm just going to go here and say Control V. Now I got it. And now I'm able to move it down. So, well, I was hoping I could move it down. Use your imagination, and I can't make it work easily. My problem is that if I move it, it just won't take it to where I want it to be. I might be able to do it this way. Nope. I'm supposed to be able to move it over here, but it doesn't want to do it. But that's okay. I hope you get the idea anyway. That we need to point it down. Now all of that is being done in C++ in this program. And if I run this program, you'll get the output I show. Now that's what I want to do in this particular video. I will probably create another one where I go through this in more detail. But I think this is enough for now. What I'm going to do is I'm going to put this video out on the on YouTube, and I'm going to put the pointer to it inside the Sakai. So long. I won't meet tomorrow. This will be what we would have done tomorrow. And sometime, either tonight or tomorrow, I'm going to try to get a program for you to write to use pointers.